My name is Andrea, and this is Taylor, Derek, Trenton, and Madeline, and we are OCHS! Okay, the effects of raised pH through the addition of lime on wild-type and mutant Arabidopsis thaliana plants. So some background information, we wanted a natural way of raising the pH, and so we chose to do that through the addition of agricultural lime, which is also used in commercial agriculture a lot, and we raised the pH to 7.5, and we watered and treated every Monday and Friday, and we did 20 grams of lime per liter of water. And then our mutant and wild-type experimentals were fed the lime mixture, and they were fed for the same amount of time and kept under the same light as were all of our plants. And our hypothesis was that the wild-type experimental would perform the best, the mutant control would do the worst, and the mutant experimental and wild-type control would perform somewhere in between those two. And so all plants mainly look the same before the lime was added, as you can see in the picture. And the lime solution was added 15 days after planting.
So this graph shows phase 1 of our experiment, which was measuring the width of the wild type and plants. So as you can see here, when the plants first started sprouting, they all grew at basically the same rate and same width as each other up until day 15, which is when the lime treatment was introduced. And here you can see after day 15, the width starts to diversify the most, with both mutant plants having a wider width than the wild type plants, with the mutant experimental plant growing the biggest width out of them all. And so the reason we measure the width of the plants is because the bigger the width, naturally the more healthy a plant is. And so what we can show from this is that since the wild type plants had a shorter width than the mutant plants, we can conclude that the wild type plants were under more stress, which causes them to intake nutrients faster to reach the reproductive stage faster than the mutant plants. And the reason we think that the reason why the mutant plants did so well in a higher pH was because the absence of the Ab2 mutant it caused the plants not to intake nutrients as fast as the wild type plants did, which ultimately led them to be healthier overall than the wild type plants.
All right, given the data collected and shown in the graph before, we have gathered some pictures that better prove the mutant experimental having the largest rosette width of the Arabidopsis plants. In this picture, taken on September 25th, 15 days since planting, you can see all the Arabidopsis plants look similar. But on October 1st, 21 days since planting, you can see the mutant experimental has a slightly larger rosette width compared to the other plants. On October 8th, 28 days since planting, you can see the mutant experimental has a significantly larger rosette width compared to the other Arabidopsis plants. And on October 12th, 32 days since planting, although they do look kind of dead, you can still see the mutant experimental plant having a larger rosette width compared to the other Arabidopsis plants.
This graph represents phase 2 of our experiment and shows the average bolt height of wild-type and mutant plants. So as you can see, the mutant control represented by the blue line is the best by far and had the highest bolt, followed by the mutant experimental, the wild-type control, and with the shortest bolt, the wild-type experimental. We believe that this was due to stress on the plants because we were very surprised to see that the mutant control was first, as the mutant experimental was typically above all other categories throughout the whole of our experiment. And the steep incline shows that the plant was growing extremely fast, and because we know that a plant typically enters the reproductive stage faster when it's stressed, that the steep increase as well as plateau out around 40 days is probably due to stress. Overall, this unsupports our hypothesis because we predicted that the mutant control would do the worst, and clearly it did not.
As shown before, the mutant control has had the largest bolt height toward the end of the experiment. Here are some pictures that help follow the trend of the Arabidopsis plant growth height. So in this picture taken on October 5th, 25 days since planting, you can see the mutant control has a larger bolt height compared to the other Arabidopsis plants. On October 1st, 21 days since planting, again, you can see the mutant control having a larger bolt height compared to the other plants, although this is a little earlier than the first picture. On October 5th, 25 days since planting, again, you can see the mutant control having a larger bolt height compared to the other Arabidopsis plants. And on October 8th, 28 days since planting, again, you can see the mutant control having a larger bolt height compared to the other Arabidopsis plants.
All right, so unfortunately, our other group member, Annalise, was not able to attend because she was extremely sick. So I will be covering her slide. Sorry, I gotta find her place on the slide. All right, so as you can tell from the phase 3 of, this is the graph of phase 3, which is the seed pod yield of the plants overall. So as you can see from the graph, both the mutant groups for plants are once again in the highest for the seed pod yield, and the wild types are once again have the lower seed pod. So we expected to see more seed pods from the mutant plants than the wild type plants based on experiments done on the Washington State University, with wild type control having the least and wild type second at the least. This was not, in the Washington State University's experiments. It is surprising that we see the mutant experimental grow the most seed pods because it had the second lowest bulk. Higher bulks are signs that a plant is more reproductively healthy than shorter plants.
As stated previously, the mutant experimental had the highest average seed pod yield. In these pictures, we are comparing each group's Arabidopsis plants and each individual Arabidopsis plants in each group. So for group 4, taken on October 12th, 32 days since planting, you can see the mutant experimental has a larger average seed pod yield compared to the other Arabidopsis plants. Same goes for group 3, taken on October 15th, 35 days since planting. You can see the mutant experimental here having a larger average seed pod yield compared to the other Arabidopsis plants. This picture from group 1 taken on October 16th, 36 days since planting, you can see the mutant experimental has a higher average seed pod yield compared to the other Arabidopsis plants. And following the same trend, group 2's picture taken on October 22nd, 42 days since planting, you can see the mutant experimental having a higher average seed pod yield compared to the other Arabidopsis plants.
Right. In conclusion, the data we collected from the experiment did not support our hypothesis. We thought the wild type experimental plants would grow the best because of the positive effects of Lyme, and they would have the APT2 gene, but they actually grew the worst. We also thought that the mutant plants would grow the worst because they would have the disabled APT2 gene, but they actually grew the best. To further explore this experiment, we can test the different chemicals that make up Lyme, because we don't know if the results we got were because of the raised pH or because of the specific chemicals in Lyme. The big question for this experiment was if we could replace pesticides with the disabled APT2 gene. The disabled APT2 gene did not harm the plants at all. In fact, it actually helped the plants grow better in rosette width, bolt height, and seed pod average. Even with the raised pH, the APT2 gene was able to keep the mutant plants thriving.
Does anyone have any questions? Go ahead.
What higher pH is your
Sorry.
How much higher was pH the experimental group?
So we use hydrated lime, which we just put the lime into water to raise the pH of our experiments of root soil to 7.5, which doesn't seem like a lot, but it obviously had an effect. Anyone else? Mr. B mentioned that the plants this year were a lot smaller, and since we never seen plants in previous years, we didn't actually notice that. But now that you pointed out, I think that. Any other questions?